Hi, so in this video we're going to cover how to create aim offsets for your character. And of course we are going to do it from scratch because I've already done this. I'm having an aim offsets folder here, as you can see, with the aim offset inside. So the first thing we need to do is to go to our blueprints folder, and then you can go to your characters folder, and you can right click, create a new folder, and you can call it AO, just like I have done, or you can call it aim offsets, which is more clear and easier to understand. So I'm gonna leave my AO there, but I'm gonna delete it later, and I'm gonna keep this aim offsets folder. So let's go into the aim offsets. Just like blend spaces, we need to create an aim offset file or asset. So what you need to do is right click, go to animation. You can see that just like blend spaces, we have a two-dimensional version of this, and we have a one-dimensional version. Because if you look here, you can see that we have aim offsets, we have blend spaces, but there is a 1D version of these as well. If I go to legacy, you can see that we have an aim offsets 1D and blend space 1D. We are going to use a new one, aim offset 2D. And just like blend spaces, you need to select the correct skeleton. And this is for a Revenant skeleton, so I'm going to select that. I'm going to call it AO Revenant. Let's open this up. And it's always a good practice to first, go to the axis settings and configure this before you do anything else. So I'm going to, for the vertical axis, that's the pitch. Pitch means, well, rotating up and down. And for the horizontal axis, this is yaw. You can see it as the character's head looking left and right. That's yaw. We're going to set the minimum maximum values to -90 and 90. Snap the grid. The same goes with the pitch. And snap the grid. Snap the grid will snap those animations to the closest point, I believe, when you drag them in. It makes it easier to work in this AR Revenant asset file. So I usually always start with the center one. If you look here, we have those file names or animations with different name endings. AO as in aim offset, and then we have CC as in center center, CD as in center down, and CU as in center up. And the important thing to also understand about aim offsets is that they are additive, which means they add to basic animation. To some basic animation, these will be added to. So let's take a look what I mean with that, because if you look, we have a preview base pose, but let's first drag in this one. You can see it says idle AO center center. And first off, the base pose is wrong because this animation is additive and we want to add to a very basic pose. It's not this one. You need to select the idle one. It's usually one frame, also a pose of one frame only. So if you select idle one, you can see that it looks correct. So what do I mean with additive? Before we proceed, I'm gonna open this idle AO file. If you open this, you can see that if you go down, you can see additive settings. Additive animation type is mesh space. That is correct. It should be mesh space. And if you look at the base pose type, this is what we are going to add onto. Okay, so this center animation is really added onto this idle AO center. This is a base pose. Okay. So it's added onto this because it is additive. Let's take a look at another one, a better example. Let's go with AO center up. Look here, uh, you can see that the same settings apply here. We have additive animation type, mesh space, and both base pose type. This is the selected animation frame. Yeah, it's one frame we have selected, and if you look at this animation here, it's added onto this frame. Okay, and again, this frame is idle AO center center. Okay, so this up animation is added to this idle AO center center. I'm gonna open this up one more time. You can see that this is idle AO center center. So we are adding onto another animation. Um, so these animations having an AO in their name, they are additive. You can also see that on the settings for them. If I go to the settings, as I just showed you, you can see that these are additive. So let's take a look at base post. It says select animation frame. It says idle AOCC. I'm gonna open this idle AOCC. If I open this animation, um, you can see that it looks like this. And let's see, base post type. Um, the base post type is idle AOCC. So we are using this animation as a base post type as well, which is the base for all of our additive animations. So these additive animations, you can see all of them really, idle AU, left down, and so on. They are using the same base. I'm going to open another one here. Let's take this one, which is left down. And you can see that it's still using the same base frame animation. It's one frame only, idle AOCC, and this is added onto that animation. So from that base, we are, well, doing this animation. Okay, so they have a common base, all of them, and these animations you can see here are additive, which means they are being added onto that base animation. So this is how additive animation works. So it's really important that you have a set of additive animations and you know which base animation you are going to use. In this case, for this character we have downloaded, we have everything we need, so you don't really need to create your own assets or animation frames, if I may say it like that. You can actually create your own animation frames like this. Maybe I'm gonna show you how to do that at the end of the video, but for now, I want you to just understand what additive is and how the configurations are and the fact that they are added onto a base animation. And this is the base animation is added onto. Previewing animation idle AOCC. Alright, so it's really simple math here. So let's go back. And I need to open up the Revenant aim offset file because we need to add everything we need in here before being able to use it. So we have center center. If you hold down the control key, you can also see the animations and how they behave when you move around. The idle AOCC. We have, well, center down. And then we need to change the base for this. I don't know, it's quite annoying, but we need to change it to idle for all of them here. Preview base pose needs to be idle. And let's see, so we have center down and then we have center up. So I don't know why this happens, but preview base pose is completely wrong here. You need to change it to idle again for all of them. And let's add the other ones. We have, well, AO left bottom. Let's see, AO left bottom center, I think. Left BC. Let's just wait with that one. If this is left center, and the same goes with this one. We have left down. And then we have left up. So I'm gonna quickly add these now that you know what these are doing. Right center. Right down. And then we have right up. Oh, wrong one. This one. So now you can see that if I hold down the control key, you can see how the character behaves. As you can see, this is exactly what we want. And now we have the values properly well set here for the yaw and pitch. I'm gonna save this. Let's go to the animation graph. You can see that from last time we are having this ground loco, which consists of our animation states, jumping and all that stuff. So let's go back. In order to use our animation Revenant, let's see which one is mine. I'm having two of them because I need to delete the other folder. So I'm going to delete the other folder now because I don't need it. It has its own aim offset as well. I'm going to delete it. Force delete. I'm not going to import anything. I'm going to click on cancel. I'm going to save all so I don't lose any data. Alright, so this is my aim of the Revenant. This is so you just drag this out just like an ordinary animation. And you can see that it looks like this. Since this is two-dimensional, it requires the yaw and pitch for this axis we just created. So I'm gonna connect this in here, and what you can do, okay, just for educational purpose, I'm gonna delete these as well to show you what I'm doing. So the yaw, you can just drag from here and promote to a variable. Let's try again. Promote to a variable. Drag from here, promote to a variable. So we need to calculate these because currently these are really not doing anything. So we just connected the logic here. Now we need to do some simple calculations. So I'm gonna go to the event graph, and as you can see, I've already done some testings here. Well, let's do this together. I want you to create a new function by clicking the plus button here, and you can name it yaw pitch calc, or any other name you want. I have several of these, so I cannot use the exact same name. And really, before doing anything else, you can go back to the Revenant character and make sure that we are not using the desired controller rotation. Because otherwise he will try to rotate horizontally, looking left and right, and we don't want that. So make sure this is unchecked. Alright, so let's go back to the ABP Revenant, yaw pitch calc. To make things easier, I'm gonna, let's see if I can. I'm gonna close some of these because I'm having too many of them. Alright. So, in order to do this, but I'm gonna do this. I've already done this, but I'm gonna do some copying to make life easier for us. And so what we really need to do is make sure you have a reference to the BP Revenant because we did create that in the earlier lessons. And if you don't have it, I'm gonna quickly show you how to do that. If we go to the event blueprint initialize animation, I'm getting the palm owner, casting it to Revenant, and just promoting it to a variable. And this is for easier access, of course. So we don't need to cast every single time we want to access it. So if you go back here to your function now, you can also connect it to the last pin here. If you go here, you click on this plus, you get a third pin here, or should I say fourth. I'm gonna connect this here. You can double click on it to go inside. So what are we gonna do here? Well, we need to calculate some differences in rotation because we need to feed that animation with yaw and pitch. Yaw is basically looking left and right, and pitch up and down. So these are what we are going to calculate. And there are two different ways of doing it, really. So that's what we are going to do. So really, there is something called get base aim rotation. That is where the actual character is aiming, okay? Since our character is using the controller's yaw rotation, if you go here, you can see that. Let me just show you. I'm not using it here. Well, we did use it before, but if you, let's see if I can find it for you. Let's see, one moment. We are using controller input, and that is why I am gonna use the yaw rotation of the controller. Let's see if I can find it. Hold on for a second. I need to check something before we proceed. Let's search for rotation here. All right. Okay, so really, let's get started and then we can go through it. So we are getting to calculate the yaw, you need to get the base aim rotation. I'm just gonna copy paste to make life easier for us. And I'm calculating the delta in rotation. And really, it's between the base aim rotation and the controlled rotation. This is for the yaw. So let's start with the yaw. This is for the yaw down here, so I'm gonna follow this to stay consistent with what I'm doing. Let's see. So I'm gonna input this here and input this here. So we are calculating the difference between the base aim rotation, where our character is really aiming, if I say it like that, or should I say where the eyes are really looking. If you look here, it says if you have a controller, by default we aim at the player's eyes direction. That is by default the palm rotation for AI and camera crosshair rotation for human players. This is a human player for us, so this is our aims rotation. It's really where the eyes are looking, and this is the actual actor's rotation. Should I say the rotation of the body itself? Okay, so we're checking the difference between where we are aiming and where our body is really rotated against. Okay, so aim versus body rotation, and then we are calculating it here, and I'm getting the yaw here. So let's start with this one. For the yaw, we are gonna clamp this because if you look here, it's limited between -90 and 90. I mean, we are gonna do it here as well. So I'm gonna, let's see if I'm gonna clamp the yaw. So just type clamp. It should be angle. Let's see, clamp. Clamp angle, -90 and 90. And once this is done, we can update our yaw. So this is the, so I'm gonna drag out that variable we're having and just input it here. We're gonna connect it soon, but let's also do the other one because for the pitch, we are having the base aim rotation, and then I'm calculating the base aim rotation versus really the control rotation. Let's see if I can. Yeah, and the same goes here. I'm gonna just save these. I'm gonna duplicate this because the same thing goes here. We're gonna clamp the pitch. So the pitch is looking up and down, okay? So I'm getting a base aim rotation where we're aiming and comparing that to the controller's rotation, similar to what we've done down here. Let's see. So the really difference between these two here and these two here is that up here we are comparing the aim rotation with the controller's rotation, but down here we are comparing the aim rotation with the actor's rotation. Gives us a little bit of difference of results depending on what we are really looking for. Which one you really need to use depends on, the configurations you are using. If you're not sure, you should test this out and see how it behaves. Let's see, so this was for the pitch. So I'm gonna drag out this pitch, connect these. I'm gonna drag this out. All right, so I'm not gonna spend too much time on making it look good, but oh, I accidentally put this in here. It needs to be in here in degrees. Make sure there is negative 90, negative 90 and 90, negative 90 and 90. So now we have calculated the differences in rotations and clamped them. Now we have pitch and yaw, and now we can input these into our graphs. So let's go back, event graph. Let's see, where's the animation graph? Let's go back. Okay. So you go back to the animation graph, you can see that here is the Revenant, this is a ground locomotion, this is the aim of set really, and this is the yaw and this is the pitch. So I'm gonna test this out. As you can see, the character is moving up, character is moving down. And also the reason for why I'm not using the controller desired rotation, let me just show you. This one. If we use that, it will become like this. You see that he's using the controller's desired rotation. He's rotating with it. It doesn't really look good. So that's why I'm unchecking this. And also, there's one more thing we could do really to make it a little bit more smooth and look nice. So if you go back to, let's see, I'm gonna give you this as a challenge actually before we try to do this together. But I'm gonna give you an advice on what you can do in order to achieve this. So if you go to this function we just created, yaw pitch calc, you can see that we are setting these values here. But really, I want you to try to interpolate towards the target value. If you look here, the current pitch and yaw are our current value. I want you to interpolate towards the new value here. So this is really the new value we are getting out of here and clamping it before we save it. I want you to interpolate towards this new value, and you can use a function called rinterp2 to achieve this. Try to see if you can figure this out, and if you do that, the character will rotate much more smoothly and it will really look nice. So this is a very handy function to know. So pause the video and give this a try, and otherwise we will do this together. Okay, hopefully you did very well. So we're going to use rinterp2 as I mentioned. So I'm going to make some space here before we finish this and wrap it up. Oh, let's see, it looks messy. Let's see what I'm doing in my... Oh, let's see, I think it's easier if I just... Let's see if I go back to. All right, so I'm gonna drag from and do a make rotator, and we are gonna input the pitch and yaw here because that's our pitch and yaw, our current pitch and yaw. Pitch and yaw. And then what we're gonna do is to interpolate towards the new target. So let's see. If you look at these three, we need to, if I can, maybe I can do, let's see if I can, maybe I think we can do this. This is the pitch. I'm gonna add pitch here. And then we are having a new output here, so I'm gonna split this as well. We are having the outputted value here, and that's clamped to -90 and 90. I'm gonna do the same thing for the below one. I'm gonna duplicate these really down here, and this is the yaw. It's a target yaw, so I'm gonna put it in here, and then the target yaw goes in here. And we need to configure the values also, so I'm gonna do that quickly before we test this out. Delta time is the world delta time. I'm gonna duplicate that and put it in here. Interp speed, I'm gonna go with a value of 4. I don't want it to be too slow. And then we are updating pitch and yaw. So really this is how you do it. Looks a lot, but it really isn't. So I hope it's easier for you to read. So we're going with a pitch here only, and we're going with a yaw here only. Alright, so let's try it one more time. Yeah, it's much more smooth now. You can always configure the speed, but I believe a value of 4 was pretty good for the interpolation speed. Okay, as you can see, this is how you can add some nice smooth movement to your character. Feel free to, change the value if you don't feel like that wasn't a good idea. I'm gonna test one more thing. Let's go with orient rotation to movement. I want to see how it behaves. Oh, I didn't like that. Maybe we need to. No, that didn't really work well. So I'm gonna change it back. Orient rotation to movement. I'm just testing out the settings. All right. And you have this function here, inherit yaw, and for the spring arm, we can use palm control rotation, and it will rotate with the controller. It's really up to you if you want to do that, but it's possible. Or, yeah. So, configure it as you wish. Feel free to test out these settings and see if you can get the behavior you want. Sometimes I really like the orient rotation to movement, but yeah. If you want to do more complex stuff, you could configure the character in such a way that when it stands still, it uses that desired rotation, or maybe it uses this only when moving, but if you stand still, you're not using this. So you can, configure the character in such a way that you're getting a combination of both of the worlds. Sometimes you want it to use the desired rotation only when you're moving, but not when you're really standing still, and so on and so forth. You can actually configure that if you wanted to. But we are not going to go too much into, complexity in such a way. But no, I think next lecture we are going to focus on animation montages, really. So let me just quickly check what settings I have. Make sure you have turned off orient rotation to movement, because if you do, it will behave a little bit strange. All right. Let's see. Let's see how it goes. I'm gonna do some quick testings here, and it's also good for you to see. All right. No, I didn't like the orient rotation to movement in this case. So I'm gonna leave it unchecked. And let's see, for the controller, let's see what that is. Yeah. I like to have this. Let's see, you could have this inherit here. Let me try without that and see how it. All right. And if you use the palm control rotation and using inherit, I'm just gonna click on all of these and see how it behaves. And I'm gonna try with orient rotation to movement. I'm just testing out, to see how the character behaves. And I suggest you do the same thing so you learn from it. Alright, so I'm not gonna play too much, but the settings are there. You can test them out to see if you can get the desired behavior. Let's see for the pitch. No, I didn't like the pitch either. Yeah, so what you really could do in this case to make it look nice is that whenever we move, we can use the controller desired rotation. Because as you can see, he follows your rotation. It looks pretty nice, but when we stand still, we don't want to use that because otherwise he's sliding. So that's one setting you could work on if you wanted to. So I'm gonna just remove that for now at least. So this is how it looks like. And the spring arm is, let's see what settings we are having. Yeah, I'm gonna keep it like this for now. And you can play around with these settings to see if you can, get whatever behavior you like. Alright, so in the next lecture we are going to focus on animation montages, and thanks for watching, and I'll see you in the next one.